In this slide deck, I'm going to talk about virtual networking and virtual disks, and then we'll end this unit with managing virtual machines. So virtual networks, basically VMs are connected to a virtual network through HyperV Virtual Switch, which is created in the HyperV Manager. So in HyperV, it basically creates a virtualized or a software network switch. And you can manage this with the command shell or the PowerShell if you want. So each virtual switch is a separate virtual network. You can create different virtual switches to create sort of these virtual networks within your machine. There are three types of virtual switches: external, internal, and private, and we'll talk about these a little bit. So you can create, delete, and modify virtual switches in Hyper-V, or you can use PowerShell commandlets to create and configure your virtual switches. So an external virtual switch binds the virtual switch to one of the host's physical network adapters. So basically, an external virtual switch is a direct connection to the port on the host machine. So it allows your VMs to access the LAN connected to the host directly. Only one virtual or external switch can be created per physical network adapter. So if you want to have more than one virtual switch, that's an external virtual switch. You have to have one for each, one NIC for each one of those virtual switches. Although it seems kind of silly to need to do that. I guess if you had different networks, you might want to do that. Maybe if you're hosting different VMs on different networks or something along those lines. So you can use an external switch when external computers must have direct access to the VM, or when the VM must have access to external network resources. So anytime you want to have direct access to the external network, and this of course is going to be the most efficient way for these VMs to get access to that external network. So having more than one physical NIC installed is recommended for a variety of reasons. At a minimum, Microsoft recommends having one NIC for the host machine and then having a NIC for your virtual, your external virtual network rather than sharing it with the host machine at a minimum. So you can dedicate one of the NICs to host communication, the other to external virtual machine or virtual switches. When a NIC is designated for use as an external switch, Windows binds the Hyper-V Extensible Virtual Switch protocol to the physical NIC and unbinds all other protocols. So this is just a little diagram kind of showing you what this might look like. This is from your textbook, by the way. So an internal virtual switch allows virtual machines in the host computer to communicate with one another, but it does not give VMs access to the physical network. So an internal virtual switch basically only allows your VMs to communicate with each other and the host, but it doesn't allow them to get outside of the host machine. This is probably good for things like testing networks or testing machines, or anything where you want to try to air gap as close to air gapping as you can. So the virtual switch is created, but it's internal to Hyper-V and it cannot be seen on the host computer. And this is basically what it would look like. So it allows your VMs to just communicate with one another. A private virtual switch is similar to internal, except that the VMs connected to the private virtual switch can't communicate with the host computer. So with a private virtual switch, there's no communication with the host computer. They can only communicate with one another. They cannot communicate with the host computer. So it's used when you want to isolate your VMs connected from the network from all outside communication. So for example, if you were going to test a virus or something like that, you want to make sure that it can't communicate with anything. This would be a good option to do that, a private virtual switch. And this is just again, another diagram of what that might look like. So if you want, you can isolate VMs in their own private network, but if you want them to be able to access other private networks or an external network, you can do that a couple different ways. You could create an external and a private virtual switch, and then configure one VM with two NICs, so then it would act as a router between those two. You could create an internal virtual switch and enable routing on the host machine so that it routes between the internal and the physical. In other words, you can either turn your host machine into a router, or you can have two different virtual switches and have one of your virtual machines straddle those two switches so it can act as a router. Either way, you have to have something that ends up being a router. And basically what you're doing is you're using Microsoft Windows as a router at that point, which is not always the best way to implement a router, but this is probably the only good option you have. Although I would say another good option would be you could spin up a Linux virtual machine, which Linux makes great routers, and you could have that straddle two different NICs and use it as a router. And I'm sure you've taken some other classes where you learned about IP tables and how to set up routing in Linux, and it's certainly not hard to do, but that would be another option. And it wouldn't use a lot of resources either, because Linux is a very efficient little operating system. So that'd be a good way to do this as well. Of course, it wouldn't be in the Microsoft ecosystem, but that's okay. There's lots of things that we do on our networks that are not Microsoft. Certainly, I would advocate for using whatever is the most efficient platform. So virtual LANs enable you to create subnets or broadcast domains on a single external or internal virtual switch. So when you enable VLAN identification, you can choose the ID number in the Virtual Network Manager, which is the VLAN identifier for the host network, and all machines that share a VLAN ID can communicate with one another as if they were on the same subnet. Basically, if you're familiar with VLANs, you can basically use your virtual switch. You can use it if it's a physical switch that has VLANs. So all of the computers that are connected to a like VLAN ID can communicate with one another. And that's basically how VLANs work. I'm sure you've learned about VLANs in your networking classes. Hopefully you've had some networking classes. And this works very similar to that. So that's basically how that works. So it must be configured with an IP addresses that have a common network ID. In other words, if you have multiple machines on the same VLAN, just because they're on the same VLAN doesn't mean they can communicate if they have different network addresses. They still need to share a common network address. Otherwise, they're going to try to send traffic through a router, which they may or may not be able to do. So it is important to have the same network. So, traditional networking still applies here. It's really exactly the same as the traditional network. You're doing exactly the same thing. All right, so there's some advanced configuration tasks. You can configure MAC addresses, advanced features on network adapters. You can enable SRIOV, which we'll talk about in a little bit. So MAC addresses is kind of interesting. It's, you can do that in a physical machine as well, but with virtual machines, it's kind of easy to just go in and create whatever MAC address you want for your virtual machine. But you have to be careful. You want to make sure that if you set a MAC address and you make a copy of a machine, that you're not using the same MAC address in lots of different places, because that could mess up your networking for sure. So VM network adapters must each have a unique MAC address on the network. So HyperV must assign a MAC address to each network adapter connected to a virtual network, and they're assigned dynamically from a pool, and the pool contains 256 addresses by default, but that can be changed. You can also expand that pool if you like. But as I said before, you can also change that the MAC address as well, so you can manually set that range if you want to. So in the Advanced Features dialog box, you can configure some other features and security options. So you can configure the MAC address, like I said before. You could enable MAC address spoofing, which allows you to masquerade as a different MAC address. You can enable DHCP guard, router guard, protected network, port mirroring. So there's some features that you can enable and play with in VM, in Hyper-V. You can enable SRIOV, which enhances your virtual network adapter's performance. So basically, it allows the VM's the virtual adapter to bypass the virtual switch software on the parent partition and communicate directly with the physical hardware. So in other words, it's a little more efficient, right? You can get a little bit more performance if you're connecting directly to the NIC. The problem is if you do this, so if you're going to use SRIOV, the first problem is you have to make sure that the NIC that you're using on the host machine can support this. Not all NICs can support this. If you have a NIC that's not supported by the guest operating system, without SRIOV, it usually works because it's abstracted through that virtual switch software. But if you're bypassing that, you have to make sure that the NIC supports that. So that's the first thing. You also have to make sure you enable the SRIOV in the virtual switch manager when you create the external virtual switch. And also, you may have to install drivers on your virtual machine, because now the virtual machine or the guest OS now has direct access to that NIC. You may need to make sure that it has the necessary drivers to work with that NIC. So that's another step you may have to take. So NIC teaming allows multiple network interfaces to work in tandem to increase available bandwidth. This is supported with VMs. So you can do load balancing and fault tolerance with your virtual machines. So on VMs, you can use the same procedure as on a physical computer. You can enable NIC teaming only on VMs that are connected to external virtual switches. So again, it only works with external virtual switches. It would be kind of silly to do this on a private switch because there is no actual VM. So it's all in software at that point, so it doesn't really matter. So if NIC teaming is configured on the HyperV host server, configuring on the VMs running in the host is not necessary because it's going to do it for you on the host. So if you could just do it one time on the host, and you should be good. A synthetic network adapter. So basically, network adapters that use synthetic drivers in Hyper-V offer much better performance than legacy network adapters. Basically, a synthetic network adapter is one where the operation of the NIC is abstracted through software, essentially. They're available on Generation 1 VMs only if you have the integration service installed. And with a Generation 1 VM, you should use a legacy network adapter in the following situations: if the guest OS doesn't support synthetic network adapters, or you need Pixie Boot, which is booting off of the network. Which again, we didn't talk too much about that in this course, but if that's a requirement, then you would want to use a legacy network adapter if you're using a Generation 1 VM. You may also need to connect your VMs using Fiber Channel. So we've talked about Fiber Channel before. Fiber Channel we usually talk about with storage, which we're going to talk about in just a few minutes when I talk about virtual disks. But in many cases, you're going to want to have your virtual machines get direct access to Fiber Channel, so they have direct access to storage over Fiber Channel from their VM. So it kind of cuts out that middle layer on the host machine. It's going to be a lot more efficient. So you can do that with Hyper-V. So with Hyper-V, your virtual machines could mount directly to the to Fiber Channel to mount those virtual disks. So again, it'll be certainly a lot faster, and you can definitely do that with Hyper-V. And that would be a good way to do this. This is what the dialog box looks like in Hyper-V if you want to set up access to Fiber Channel. So again, if you're using Fiber Channel SANs, then it would be a good idea for your VMs to be able to access their virtual machines. And why would you do that? So we're going to talk about virtual hard disks now, so it kind of segues way nice into this. If you wanted to cluster your virtual machines, it would be a good idea to have a shared storage platform. That way, multiple physical host OSs can host your virtual machine. So if one physical machine goes down, another physical machine could take over hosting that machine in a cluster. And Microsoft does support that. And we'll learn more in the follow-on to this class. We talk in more detail about how to do high availability with Microsoft Windows, including how to do this with Hyper-V. So with virtual hard disks, you can have three types. You can have a fixed size, you can have dynamic expanding, or differencing. So a fixed size is when you create your VM, it's going to ask you how large you want your disk. And if you say you want a 20 gig virtual disk, it will create a 20 gig file that has your file system for your virtual disk. The thing is, if you're only ever going to use maybe 5 of those gigs, then it's not very efficient because you're using a lot more space because you're just storing a bunch of nothing in that file. So the other option is dynamically expanding, where as you begin using that virtual disk, it's going to expand the file as you're using it. So the advantage there is that the file is going to grow with your virtual machine, and it's much more efficient in storage space or storage utilization. However, it is slower because it has to constantly grow that file as the disk is being used. So that is something to be aware of. Differencing uses a parent-child relationship where there is a parent. The parent is a dynamically expanding or fixed disk, and the child is a differencing disk. So a virtual disk can be created when the VM is created or with a new virtual hard disk wizard. So even after a virtual machine is created, you can create additional disks if you like. You can specify certain aspects of a virtual disk. You can do compact, convert, expand, or merge, and also reconnect. This is what the dialog box looks like, and there's a little explanation of each one of those options here. So a pass-through disk is a physical disk attached to the host that's placed offline so that it can be used by the VM instead of in addition to a virtual disk. In other words, what you could do is, let's say you had a SAN, and you're allocating space on your SANs for your virtual machines. Theoretically, you could use Fiber Channel to connect to that on the host machine and simply keep them as unallocated disks in the host machine, and then your VM would be able to mount those disks and use those disks natively, as opposed to using them as files. So instead of you having a file that's your virtual disk, it could literally be a disk. And that's a pretty efficient way to do this as well, using pass-through disks. So it has a modest performance advantage over a virtual disk. In my experience, a little more than modest, but according to your textbook, it's a modest advantage. But it lacks the flexibility of a virtual disk. In other words, if you decide to move a virtual machine to a new machine, you have to move that actual disk. There's no file that you can copy. You have to actually move that physical disk, and then you can mount it to the other machine. So it does get a little bit kludgy in that sense. So some of the advantages of pass-through over VHD. So a VHD is limited to 2 terabytes, but when you use an actual disk, you don't have that limitation. So 2 terabytes is pretty big for a virtual machine, I think, for the operating system. So kind of a common approach here is to do a hybrid where you might do a virtual disk for the operating system, but then your pass-through disk would be for data storage. So for example, if you have a server that needs a large data store, you could use a pass-through disk for the large data store, and it might be the D drive or the E drive or something along those lines, but your actual operating system might run as a virtual disk. So storage quality of service enables you to specify minimum maximum performance values for virtual hard disks. So that limits the VM's access to a virtual hard disk to prevent it from consuming too many storage resources. In other words, if you have a shared storage platform, you're going to want to make sure that you can set what this quality of service is on the storage platform. That way, a single virtual machine isn't saturating the storage platform, saturating it with disk I/O, thus locking out other virtual machines from utilizing that disk. So in a shared environment, it's kind of important to use quality of service. So moving on to our last section here, we'll talk about managing virtual machines. So this is some additional features that you can use to manage your virtual environment. You have virtual machine hardware settings, integration services, automatic start and stop, managing checkpoints, resource metering, enhanced session mode. So let's talk about some of these. So for virtual machine hardware settings, you can configure BIOS and firmware settings, just like you can on a physical machine. So, when you're booting up a physical machine, you can hit the delete key or F2 or whatever it is to get into BIOS and make changes, or UEFI. You could do the same thing with your virtual machine with HyperV. You can allocate memory to your virtual machines. You can make dynamic memory, so it's only using the memory that it needs, and you can have, what dynamic memory allows you to do is, let's say you've got 10 virtual machines and you have 10 gigs of memory. You could assign 2 gigs to each virtual machine, but it's very unlikely that all of those machines are going to be using 2 gigs. So you can over allocate your memory. You can over allocate resources, and it allows you to much more efficiently use the resources that you have. Because like I said, it's very unlikely that every machine would be using all of those resources. So when one machine is busy, it uses more resources, and then when it backs off, another machine's picking up needs to pick up more resources, it gets those resources, and so forth and so on. So it's a little bit more efficient. You're using more of the resources on the host computer than you would otherwise. You could use smart paging, which again you can configure from the hardware settings, virtual processor settings. In other words, how many cores each machine is being assigned, and things like that. You can set the affinity for your virtual machines to the processor. So with the BIOS settings, with a Generation 1 VM, you can change the order in which the VM's BIOS searches for a boot device, just like you could on a physical machine. On Generation 2, the category is firmware instead of BIOS. It does support UEFI. So again, you can use that to select the boot order. We talked about memory allocation already. So again, you can more efficiently use memory. You can use dynamic memory to more efficiently use memory, as I explained earlier. And by the way, it's not enabled by default, but this is what the dialog box looks like in HyperV if you're going to set that up. And smart paging, which I didn't talk about before, it basically HyperV can use a file on the host computer for temporary memory when there's a sudden surge in memory requirements that exceeds your physical memory. So if you have over-allocated memory, rather than shutting down virtual machines, it just simply uses a paging file. So this works with dynamic memory, as I explained before. And like I said before, you can set the affinity for your processors for your VMs, and this is what the dialog looks like in HyperV. So Integration Services provides drivers for the guest operating system and improves performance and functionality for IDE and SCSI storage devices, network interfaces, mouse and video drivers. So basically, when you install a virtual machine, you would want to install Integration Services, which gives you these additional tools for managing your virtual machine. So it offers additional services: operating system shutdown, time synchronization, data exchange between the VM and the host, a heartbeat monitor, backup for volume checkpoint, guest services, and so forth. So some additional things, like even things like copy and paste. You can copy and paste between the VM and the host OS, for example, when you install these services. Automatic start and stop actions specify how a VM should behave when the host computer starts and shuts down. So you can configure it so that if you shut down the host, it automatically shuts down the virtual machine, and then when the host turns back on, it automatically brings the virtual machine back online. So you can have it sort of mirror what's happening on the host machine, and you could also put a delay on that startup. You can have it do nothing, so you can have it where it just, when the host shuts down, it just disconnects the other machine. You could theoretically do that. You can have it do nothing. You can have it so that when the machine starts up, it doesn't start your virtual machines. In most production environments, in my experience, you probably want it to mirror the host machine. The only exception to that being when you're running in high availability. So if you're running a high availability environment with HyperV, you may not want the machine to stop because another machine is going to take over that VHD when the host machine shuts down. But again, you'd have to configure all that, but it is possible to do that. All right, so we talked about automatic stopping. So checkpoints can be used to revert to a previous state, as we discussed before. You can create up to 50 checkpoints per VM. So they're useful for testing in lab environments. So you can take sort of a snapshot in time when you're doing something. So if you're testing some build with software or baselining or something like that, you could take a checkpoint or save a checkpoint, which we discussed earlier how to do that. And you can roll back to that later on if you need to. So some issues with it. They're stored on the host system's volume by default, and you may need to relocate it to a different disk because they can get rather large. You should always use HyperV Manager to delete checkpoints rather than just deleting them from the file system. The actual checkpoint file isn't deleted until the VM is actually shut down, and checkpoints do decrease a VM's disk performance. Checkpoints have to be deleted before expanding a disk. They can't be used with pass-through or differencing disks. In other words, if you're using a pass-through disk, you can't do a checkpoint because it's not a file, it's an actual disk. So it doesn't work with a pass-through disk. It works more like a, your VM will work more like a traditional computer in that case. So there's two different ways to use the save checkpoint. You can revert, which returns the VM to the state when the most recent checkpoint was taken. And you can apply, which allows you to select the checkpoint to apply. So if you want to go further back in time, for example, you could do that. With resource metering, a HyperV feature allows vendors of large-scale virtualization to measure customer use of VM resources for billing purposes. So you can basically look at the average CPU, incoming and outgoing network traffic, minimum, maximum, average physical memory usage, and so forth. So you basically can look at the usage of all of these different resources. And I think it's more than just for billing. I think this is a good tool for monitoring your virtual environment as well to see if you have the appropriate hardware, if there's, a lot of times what happens in environments that I work with is there'll be a period of time when virtual machines are unresponsive or something along those lines. And we'll try to troubleshoot that so we can use this resource monitoring to see what's happening on all these virtual machines when we're having some issue of that nature. And it's just like everything else. You can do this with the PowerShell as well. I think it's the first time in this course I didn't say the command shell by mistake. So again, we can use resource metering to keep an eye on the resources or use it for shared environments or large enterprise environments where we're billing for usage. And by the way, that billing isn't necessarily billing customers. In many cases, it's billing departments, right? So if you work in a large enterprise and you're an IT department, you're probably servicing many different departments, and those departments have individualized budgets. And if everyone's on this huge shared environment, we have to have a way of understanding which departments are utilizing the resources so that we can take the money from their budgets more equitably, right? So it's not really fair that all the departments pay equally for IT resources if one particular department is using a lot more of those resources. I'll give you a good example. I work in healthcare. I work mostly in radiology departments in healthcare. And radiology traditionally is the #1 user of resources in the both network and storage. We produce much more data than most other departments. In fact, in most hospitals, radiology produces more data than all other departments in the hospital combined. So radiology usually pays the lion's share of the IT bill for storage. They're mostly responsible for storage. with a typical hospital that has 100 terabytes of storage, radiology is probably using 90 of those terabytes. So it's only fair that their budget pays for most of that. It wouldn't be fair that that comes out of other departments' budgets. So again, you can use these tools to kind of monitor that utilization, because with virtualization, a lot of the lines get blurred as to who's using which resources, because it's all one giant platform now. So it makes it a little bit more difficult to figure that out. All right, so enhanced session mode is a feature that improves interaction and device redirection between the host computer and VM connection console. So for example, if you, I don't know why you'd want to do it, but if you want to listen to music in your VM, you can redirect that to your host machine speakers, for example, or the microphone. You can redirect the printer connections, USB devices. So when you plug in a USB stick, it can redirect that port directly to the VM. Otherwise, the host machine is using that. You can redirect drives, plug and play devices. Display configuration can be enhanced, so you get much better display when you use the enhanced session mode. And you can copy and paste with the clipboard, files, folders, and so forth. So if you're going to be using a virtual machine from the console, it's generally a good idea to install the enhanced session mode. It certainly makes things a bit easier. So to use enhanced session mode, you have to enable it in HyperV Manager and in the guest operating system. So you have to verify that remote desktop services must be running on the guest OS. You must log on to the guest OS with an account that's a member of the local administrators or remote desktop users group in order to use the enhanced session mode. All right, so we talked about virtualization and emulated hardware environment. We talked about using it for lab and test environments. HyperV is a Type 2 hypervisor. So we talked about that. We talked about HyperV installed as a server role in 2013 in standard and data center editions. We talked about the licensing with standard and data center, how you can run one with standard, but you can have many virtual machines with data center. With data center edition. We talked about using HyperV Manager to create your VMs. We talked about the different types of virtual networks, the external, internal, and private. External being connected directly to external networks. Internal, where it's an internal network, but it does have access to the host, but it doesn't have access to the external network. And private, where the VMs only have access to each other, but not to the host or the external networks. But we could set up a router between the two and route traffic if we wanted to. There are three types of virtual disks, which we talked about: dynamically expanding, fixed, and differencing. We talked about the configuring the physical environment and BIOS settings, memory allocation, processor. I talked about resource metering for billing purposes, or at least for monitoring resources within different departments, and that's it. So this presentation concludes all the material for this course.